To use the spreadsheet, macros must be enabled. The Excel add-on at risk is required to run a probabilistic analysis, but is not required to run a deterministic analysis. The yellow shaded cells are where the user will input data, and the white cells are built-in calculations. Gray cells do not require an input. Whenever you are copying and pasting input data, always paste as values because many of the cells are conditionally formatted. Also, to add reference lines on plots for key stages of interest, there is a table at the bottom of the cover sheet tab that you can fill out. For each worksheet, the top left corner will turn red if there's an error present in the worksheet. Sheets with errors will also be listed at the top of the Simulation Results tab worksheet. Also, the entire left side of all worksheets will turn red if the spreadsheet is populated with the at-risk simulation results. Always clear the simulation results prior to running a new simulation to shorten the run time, because it will take at-risk a very long time to start a simulation if you do not. Starting with the Hydrologic Hazard tab, select the vertical datum from the drop-down menu or type in the project datum into the box. Remember, the elevation datum must be consistent across all spreadsheets. Next, copy the inputs from the RMC stage frequency distribution spreadsheet and paste these values into the table. Once that is complete, input the stage elevations lowest to highest that will be used to define the system response curve for the failure mode. If the system response probability has a known 0 point, set the first stage to that elevation. You can always come back to this tab in the workbook to add more peak stages, but the low to high order must be maintained. There is also a plot of the stage frequency curve on this tab. Do not freak out if the mean at-risk markers do not plot on the expected curve at this point. They will not plot on the curve until after a simulation is run. Next, let's move to the Life Loss tab. Here, input the day and night exposure rates. Remember, the exposures must sum to equal 1. Next, select the life loss distribution, then click Execute to populate the other worksheets. You can choose between beta general, beta pert, triangular, and uniform distributions. Of these, beta pert and triangular distributions have been the ones most commonly used. More recently, risk assessment teams have been using percentile sampling, which samples the consequence data directly instead of trying to find a representative distribution. This is also an option in the drop-down menu and has become the preferred method because it best recreates the results from the consequence model. In this worksheet, the table headers and cells that are shaded yellow to denote a user input will change based on the requirements of the distribution. Unused cells will be grayed out. Next, input breach life loss estimates for day and night. The estimates need to be input in order from lowest stage to highest stage. If the distribution is not selected, the spreadsheet will default to the most likely value. Scrolling down within the same worksheet, we'll do the same thing for the non-breach life loss, inputting the estimates in order from the lowest stage to the highest stage. If you want to use a static value for a given stage instead of a selected distribution, override the mean value for that stage and leave all other columns blank. This can be done in the breach life loss table as well. Inputting the economic cost is also done in a similar fashion. The estimates for breach and non-breach are input in order from lowest stage to highest stage. Uncertainty in the economic cost is typically not considered, so there are no options for distributions. The peak stages for economic cost inputs should be the same as the peak stages for the life loss inputs from the prior worksheet. We are now ready to start with the nodal estimates. At the top of the node worksheet, select the node type, failure, or intervention. Next, click on the peak stage at the top left corner of the table. This will populate the table with the peak stages to evaluate from the Hydrologic Loading tab. You can also use the drop-down to select the stages manually. The stages you evaluate for a given node do not have to be the same as those for other nodes. The only requirement is that the lowest and highest stages are the same for all nodes so that the spreadsheet can interpolate properly. On this worksheet are tables to record and summarize the elicitation responses. It is beneficial to have each elicitor use the RMC team elicitation template and email the results to the spreadsheet operator. That template is formatted specifically to be used with the spreadsheet, such that the spreadsheet operator can simply copy and paste the results as values into the table. This is much more efficient than trying to manually type in the elicited responses. If a second response is necessary, input those as well in the next table. For the second response, the cells are conditionally formatted to indicate a change from the first response. Green cells indicate a decrease from the first elicited probability, and the red cells indicate an increase. Summary statistics are tabulated at the bottom. The inner quartile is known as the middle 50, and it is the difference between the 25th and 75th percentile values. The lower this number, the tighter the spread of the elicited responses. A decrease in the inner quartile value is an indicator that the elicitation panel is moving towards a consensus. As a default, the spreadsheet reports the median of the elicited probabilities for the lowest reasonable, most likely, and highest reasonable values. But the drop-down box can be used to toggle between the median and the average of the elicited probabilities. The last table of each node worksheet is the place to input the consensus probabilities and to choose a representative probability distribution. This will be done by the elicitation team. Available probability distributions include triangular, uniform, log triangular, and log uniform. If a stage represents a 0 threshold for the PFM, enter a 0 for the lowest reasonable, most likely, and highest reasonable values. Once the consensus probabilities are input, verify that how the probabilities change with stage and that the selected probability distribution is appropriate. The consensus elicitation results and PDFs for each pool are plotted below the consensus team estimate table and will be shown on the next slide. Here is a look at the plots included on each node worksheet. The probabilities are plotted with stage, and the probability density function for the selected distribution is also provided. For the PDF, use the drop-down menu to choose the stage elevation for the probability density function you want to display. Once all the data has been input, move on to the risk calculations worksheet. Here, you will select an interpolation method from the drop-down menu to be used for the system response. Options include linear, semi-logarithmic, and z-variate. You will also need to verify the life-loss correlation matrices used in the worksheet. The spreadsheet defaults to perfect correlation between breach and non-breach life loss. To make the life loss distributions perfectly uncorrelated, click the plus button on the left to show the matrices, then change the bottom left-hand portion of the matrices boxed in red. You'll change the values from 1 to 0 for both the day and night tables. Scrolling down in the risk calculations worksheet, you have the option to include non-exceedance. Even further down is where the user will choose between a probabilistic and deterministic analysis. If you choose deterministic, only the mean estimates will be calculated. To calculate uncertainty, probabilistic should be selected, and at-risk will be required to perform the analysis. To finish setting up the analysis, you will also need to set the loading partitions to evaluate. By default, the spreadsheet generates even partitions between the minimum and maximum stage of the stage frequency curve. These partitions can be changed to provide additional resolution around key elevations. It is important to note, however, that the same set of stage partitions should be used for all potential failure modes for a given project. If all steps were done correctly, everything should be set and ready to go. As part of the final check, go to the simulation results worksheet to verify that there are no errors and that the simulation results are clear. If the simulation results have not been cleared, click the Clear Simulation Result button. Before running a simulation, it is always good practice to check the settings. The appropriate at-risk settings for a government computer should be preset in the spreadsheet. but these settings can be checked by clicking on the settings icon. Under the General tab, multiple CPU support should be disabled unless you're using a non-government computer or an air-gapped computer. Under the Sampling tab, Smart Sensitivity Analysis should also be disabled. Pick how many iterations you want, then click Simulate to begin the simulation. A dialog box will pop up related to the correlation matrices. When it does, click Yes to continue the simulation. After the simulation is complete, which may take a little bit depending on the selected number of iterations, click Plot Simulation Results on the Simulation Results worksheet to populate all the plots and tables. After running a simulation, you can use Explore Data and click the footprint to plot and cycle through the iteration results. Use the arrow keys to move from one iteration to the next. The last step is to save the file. When you save the spreadsheet, a dialog box will pop up asking you how you want to save the simulation data. When files get large, it is best to save the data as an external file. Save the data file in the same folder as the spreadsheet.